enthusiasm. So we have 27 students, very good participation. Alright, so for today, I would like to show you some insights on image pre-processing and image processing. Alright, sekejap je. Let me see. Hari tu saya dah buka dah window dia. Never mind, I open again. History. Download. Dan nak ujung-ujung ni banyak assignment.
Banyak gila.
Banyak sir, banyak
Rasa
test.
banyak saya.
Alright, so good luck to all of you. Let me open this first image processing. Tak apa, don't worry. Saya pun ada assignment kena siapkan juga. Kita sama je. Kejap kenapa dia tak nak buka ni? Okay, lambat. Okay, let me share. Share the window. Alright, can you see my slide here?
Yes sir.
Alright, so let's begin. So kalau kita habis awal, saya boleh stop kelas awal so you can focus on other things. Alright. So Bismillahirrahmanirrahim. So today I would like to explain about image processing in artificial intelligence. Alright. So basically, image processing and image pre-processing are two different things. Alright. But it actually complements each other, right? In terms of some technique or method, right, that is applied in both pre-processing and processing. Okay. So first of all, when before we can go further on image processing, we have to understand what is an image. Okay. Previously, I have already shown you an example of video processing, alright? So identifying face, identifying color of an object, kan? Kita dah tengok kan last week. So in literature term, image is a word or phrase that direct to taste, sound, hear, sight, and smell. So in general term, image is a picture is expressing oneself, right? So have you heard of the saying and a picture contains 1,000 meaning? Pernah dengar?
Pernah.
Kan?
Nah,
Right.
Pernah.
So in computer science, an image is an exact replica of the content of a storage device stored on a second storage device. So basically, an image is a file that contains a value that represents an image. Right. So furthermore, when we apply this image pre-processing or image processing, we want to do some sort of segmentation, or you want to understand more about the image itself. So later, these images can be brought up to our AI method in order to do further analysis. So let's say we want to do recognition, we want to do classification, that we have already learned throughout the semester. Kan? Kita dah belajar kan? Macam mana nak buat recognition, macam mana nak buat clustering. So basically, you have the idea on how to do all that. But for your information, okay, image pre-processing or image processing can lead to a better classifier. Okay, you can classify better and you can get a more accurate result if you are doing the right process in image processing and pre-processing. Okay. So this is an image, and an example of image of a child. So just a few examples, and then there's a image of a man, that contains so many information to be interpreted. You can say that you're going to um, identify whether this person is a male or female. What the clothes that he is wearing? Does the man have a facial hair, or is he wearing glasses? Is he smiling? Is he what he is doing? What is his job, for example? All right. So there are so many things that we would want to analyze or we want to deduct based on the image that we have. All right. So that's the reason why image processing is also important in order to help AI method to do all these things that I've already said previously. So what is image processing? So in this example, all right, in these notes, image processing is analyzing and manipulating image with the computer. And image processing generally involves three steps, right? So you have to memorize this step. So first one is import the image. The second one is to manipulate, and the third one is the output of the result. When we want to collect or we want to gather our data, if our data is an image, we have to consider what are the um, means of retrieval of the image. Is it through optical scanner, or is it through a camera, okay, through digital photography, or you have some sort of tools or technology that can produce an image in so many different format, right? You also have to understand the formatting of the image. Is the image format in RGB value? Is the image formatting is in CMYK value? So there are so many different format of images. I've also shown you this example previously in our previous class kan, kita dah tengok kan ada contoh apa tu image dengan RGB value, image dengan CMYK, and you also have image in HSV value. And then the second one is to manipulate or analyze. So the image is some way uh, um, can be included to enhancement, data compression, or analyzing pattern that aren't visible to the human eye. For example, meteorologists use image processing to analyze satellite photograph, or probably a doctor that tries to understand cancer images. All right, so is the cancer active or not? All right, so it can be many things. Even if you want to resize the image, we will consider that as manipulating the images. All right. So sometimes when you have designed your neural network model, all right. So your neural network model has needs the input to be consistent, right? Because the design of the neural network model cannot adapt to the ever changing size of the image. So you have to resize the image in order to fit to the neural network. So the process of resizing can be considered as manipulating the images, alright? And then the third one is the output of the result. The result might be the image altered. Okay, macam tadi lah kalau kita buat resize from a bigger size image, the output is the smaller size image. Or it can be a report based on analysis of the image. So the image can also produce reports. So what are the average color of the image? What is the information that is contained in the image? So the size of the image, the number of objects, alright? And then we can also understand that inside the image, we may have some sort of histogram analysis. Do you know about histogram? Pernah dengar histogram?
Pernah.
Pernah sih.
Okay. So the histogram of the image will show whether the image is a bright image or a dark image. Alright, a darker image will have a frequency value on the left side. So on the left side tu dia akan tinggi dia punya frequency. So if the image is a very bright image, so the color frequency will be on the right side. Okay, so if the image is varies with different color, so probably it will have a normally distributed frequency. Right. And then we have to understand noise, right? Because in images, you would have come to the problem of having noise in your image. And I'm sure that most of you have experienced having noise in image taken, right? So I believe everybody is using a smartphone, right? Ada tak yang tak guna smartphone dalam kelas ni? Everybody is using smartphone, right?
Betul.
Okay, so if you use your smartphone is already equipped with a how do I say it? A camera, right? So a camera that is quite good enough, right, to take a good picture. However, in several circumstances, it may occur that your images have noise. Alright, so what is noise? Noise is a random variation of brightness or color information in images produced by the sensor and circuitry of a scanner or a digital camera. So when you took a picture, for example, especially in a low light condition, when you take picture indoor, for example, and then where there's no adequate light to produce a good image, so your image will have noise, kan? Betul tak? Ada tak? Mesti ramai yang ada experience ni, kan? Am I right?
Yes.
Okay. Betul sir. Okay, how about DSLR cameras? Ada tak yang ada experience gunakan kamera DSLR?
Ada.
Okay.
Ada.
Okay, the DSLR you have many features that you can adjust, okay, in order to get the desired image quality. Alright, so let's say you are indoor and then it's very dark, you don't have a very good source of light. You can change the ISO, for example, right? So a lower ISO, meaning you have a very clear images, right? So but a lower ISO needs light. Okay, kalau tak ada cahaya, you have to use a higher ISO. So by increasing the ISO, your image will be brighter. However, it will contain noise. Okay, so just for those that doesn't know, okay, they are setting in a SLR camera where you can change the ISO. Okay, at lower ISO meaning your picture will be better, right, smoother. However, in a certain low light condition, you can increase the ISO to increase the brightness of the image. However, there are some setbacks lah. So your image will have noise. Okay, so how you deal with this? So sometimes people did not prefer to increase the ISO, okay, too much. So maybe they increase a bit the ISO, but you have other options such as increasing the shutter speed, for example. Increasing the shutter speed. So the more time that the shutter takes to capture the images, so the brighter your image is. Alright, so a longer shutter speed will produce a brighter image. So kalau contohnya macam malam-malam ke, you nak ambil gambar bintang, for example, so you need a slower shutter speed. So shutter speed yang slow tu akan kumpul cahaya. Okay, it will gather the light to produce an image so that the stars are visible. However, the setback are that you need a tripod to do it. Alright, you cannot use your hand unless if you have a steady hand lah, you boleh pegang tak bergegar kamera you kan. Then you can pakai tangan you. But then um, the setback of using a slower shutter speed is that you need a tripod. Okay, how about if you want to take images that are moving very fast? Okay, of course you need a very uh, uh, bright light source. Okay, light source you kena tinggi, and then apa tu, you have to use a very fast shutter speed lah. Shutter speed dia cepat, barulah you boleh up gambar orang berlari tu dia tidak blurry. Alright. So these are the things that you need to consider. Right? You need to understand how the data is retrieved. Then you can prevent things like distortion or noise earlier on. So how to remove noise? Itulah dia. So awal-awal sebelum you remove noise tu, masa nak capture tu, you have already um, understand. You have already understand and you know how to tackle the problem. Okay, you know that by doing these particular steps, you can prevent having noise or distortion in your images so that you don't have to do much during the pre-processing part. So yang ini contoh yang dia bagi ni adalah proposal dia, so you can just ignore this. But this is one example of removing noise is to do some sort of blur. Alright, so it tries to blur up the image, so it removes the noise. Right, so I think he is using a Gaussian blur, for example. But the problem of removing noise makes your image blurry, right? So dia ada macam you have to compensate lah. Okay? If you want a sharp image, you have noise. You have more noise. If you want less noise, then the image is blurry. See? But if you took the image earlier on, with the consideration of without you don't want to have too much noise, so during the capturing of the information you have already avoid all this so that you got a very solid image and a better raw image, so that less processing later that needs to be done. Alright, so another processing technique, okay, this is processing technique, is color enhancement. So method of electronically enhancing one or more color component, which is cyan, yellow and magenta. Just an example, it can be RGB and so forth, which together represent the chromatic component of a pixel of an image. Alright, so this is the example lah. So you have an image of a leaf, okay, on its branches. So later on, it is enhanced so that the green color of the leaves would be a lot more greener. Alright, so color enhancement are usually for aesthetic. Alright, but it does not really sometimes, okay, for some problems, it does not really represent the color of the image itself. Mungkin color daun ni mungkin memang macam ni. Okay, so you have to understand that when you do color enhancement, if color play a role in doing recognition or classification, you have to be very careful when doing color enhancement. Alright, sebab you have already tampered with the data. Yang ini you dah manipulate lah maknanya data tu. Okay, so the manipulation of data will affect the output of your AI later on. Okay, next is sharpening the image. Macam like I said earlier, sharpening of an image for making outline of a digital image look more distinct, right? So sharpening will increase the contrast between the edge pixel, right? Emphasizing the transition between the dark and light area. However, when you do sharpening, you have the risk of increasing the noise of the image. Okay, so too little sharpening can make for a soft image, but over sharpening add noise. So dia ada setback dia lah. Okay, trade off. Kan, kalau image tu blur, less noise. You sharpen the image, you get more noise. Alright. So again, it is very important that when you collect your data, okay, when the data is captured, you do it right for the first time. Maknanya data tu kalau you perlukan something yang detail yang very sharp, alright, so you probably kalau macam ni kan, yang daun ni kan, you perlukan urat-urat dia ni, urat-urat daun ni memainkan peranan untuk you buat recognition, for example. So you have to focus on the urat daun tu, and then you probably will have to choose macro setting, alright, so that you can get the patterns of the leaves pattern. Alright. So this is an example of sharpening. See, before and after the picture. So the after picture is more sharper, right? So you can see the edges, the distinct color between the petals, alright. However, you can still see there's some sort of noise. Ada sedikit noise lah. So this is probably the best or the optimum sharpening method, alright. So if you do more sharpening, then it will add noise to it, right?
Sir,
Yes.
ada orang nak
Oh, ada
request
lagi?
masuk. Ah.
Ya, aku dah habis lah. Okay. Amirul Hakimi Okay.
Yes.
Alright. Sekejap patah balik. Alah, banyak sangat saya punya tab. Okay. Segmentation. Alright. So how about segmentation? Segmentation is an example of see this one. So you have a background. Okay, you have a background image, and you know this background wouldn't change much. Okay, so when you have already predetermined a background of an image, if there is changes in the pixel of the image, you can do segmentation. Yang ini more to mathematics lah. So I will show you probably tomorrow. I'll show you how to do this simple segmentation, right? So you have an image, and then you this image you minus with this image, kan? Minus dengan image asal ni, and this one, right? So you only get the changes here. So katalah the value dekat sini kebanyakannya 10 for example. So value dekat sini kebanyakannya pun 10 juga kan, right? So 10 tolak 10 apa?
Kosong.
10 tolak 10 kosong, good. So bila dia kosong maknanya nothing is there because it's the same image. But now here the value is different. Okay, walaupun kalau value dia lebih rendah daripada background ni kan, contohnya ni 9 contohnya. Yang ni pun dekat sini pun area sini pun value dia 10 juga. However, the difference of 9 and 10 is 1. Alright. You can do an absolute value, okay, minus and then you absolute the value. So you get 1. So the difference in pixels shows that there's something changes. Something is changing in the image. Alright. So that's why dia tahu dekat situ ada orang. Okay. So even if the value is bigger, kan, contohnya kalau value dia 20 but the original pixel value is 10. So you have a difference of 10 pixel. Right. So the higher of the difference of the pixel means there's some sort of distortion in the image, and there may be something happening inside the image. So this usually applies in real time video lah. Kalau you ada camera, and that particular camera process the image in 24 frame per second. So you need a very fast processor to intercept between the images. Maknanya dalam 1 second tu you boleh tarik satu image, lepas tu you process image tu, lepas tu you masukkan balik. So that's why you get this box, bounding box. Right, so zaman-zaman dulu punya komputer susah sikit lah nak buat. So nowadays we have a very good processor, so we can do something like this. So this is segmentation, see? So when we minus with the same value kan, kita tolak je value, dia jadi hitam lah, hitam ni kosong. Okay, so this is the segmentation of the person inside the images, right? So lepas tu dia ada further preprocessing lah, mana-mana yang ada noise ni kan, ada lubang-lubang ni, dia fill up, so dia dapat gambar orang ni. Okay, so this is another example which is age detection, right, to determine the age of the image. So again, similar to what have been explained previously, so age detection is to check between the difference in contrast between two area, and the line between the contrast will become the age of the image. So sebab image ni dia banyak line kan, so the age detection is very very random. Okay, so you need to have a very good photograph predetermined previously, so that you can do a better image processing later. Contohnya macam you nak ambil gambar species contohnya. You dah ada sample, right? So you tak naklah ambil gambar sebarang-sebarang je. Okay, bila you nak train your data, you have usually people will train with clean data. Clean data means your sample with a contrast background, alright? So contohnya you nak ambil gambar jenis-jenis rama-rama lah, for example, kan? So rama-rama tu ada banyak spesies kan, ada banyak spesies. Selalunya kita bezakan antara rama-rama ni, kita bezakan dia punya corak rama-rama tu, dan juga dia punya size dia kan, betul tak? So you have to be very consistent, because the size of the butterfly will matter, alright? Unless you want to discard size, because you want the data to be taken in real time. So you need to think how to exclude size in order to understand, or in order to do classification of the butterfly species. Kalau you rasa distance, kalau you rasa size tu plays an important part in determining the species, so you kena tahu distance from the camera to the object of the image, so that you can do some sort of estimation of the size of the butterfly. So panjanglah ceritanya, sebab in doing that you are actually doing image pre-processing or processing, right? So this is another example of feature detection and recognition. Okay. So this is an image of fruit, right? So you probably want to do color segmentation, alright? So in order to determine which fruit is which. So ini orange, ni apple kan, and then you have grapes here. And probably some of the fruit would not get a full you wouldn't get some sort of full coverage on the fruit itself, tapi you boleh extrapolate the the age of the fruit. You boleh tambah, you boleh macam estimate dia punya, because you know kan, oranges should be round in shape, so you can extrapolate its size. You boleh tengok, you boleh tahu dia punya lines dia dekat sini, right? So that is also involve image processing. So this is an example of face detection, right? So face, hari tu saya tunjuk face detection kan. Now this example shows an detection of where the location of the eye, the nose, mouth and ear. Right. So this help further if you want to do further analysis. For example, if you want to do emotion detection, you want to check whether a person is drowsy driving kan. Ada student saya buat drowsy driving detection, meaning that orang yang bawa kereta dia mengantuk, so the system will alert. So that is something that has to do with the size of the eye lah. Okay, kalau macam saya mata kecil je ni, dia akan detect drowsy je. Right, so representation issues is another problem. Right? Again, like I said earlier, you have to collect the data right for the first time. Right, so back in my days, most CCTV camera has a very low resolution. Okay, see, this is the example. This is issues in data representation. So when you collect your data, sometimes you didn't realize that your capturing device ataupun your device that generates the image could not provide a very sharp images. So you have to think of a way of probably enhancing the image, or you start off with a very good capturing device, so that you don't have to go through the hassle of fixing some of the blurry image shown in this slide. Alright, pernah tengok CSI tak?
Pernah sir?
Kan
Pernah.
dia boleh zoom dekat paku, lepas tu paku tu ada muka orang, lepas tu dia boleh enhance nampak muka orang kan.
Yeah.
So so that is fiction. So at that particular time, they actually don't have that kind of technology yet. Even so, for in today's punya technology pun, you can only predict, right? You can only macam from the blurry image, you can do some sort of analysis and then you predict probably orang ni rupa dia macam mana, provided that you have the data, right? Mungkin kita boleh buat macam mapping, macam bidirectional associative memory ke kan. So kita mapkan muka orang-orang yang penjenayah ni kepada muka yang blurry, right? So that later, if any blurry faces shows up on the camera, so you can map back to the original image. However, if the image is too small, kan, the pixel is too small, you cannot do anything about it, right? So again, please remember, sekatalah mana tahu kan later you dah kerja nanti you jadi consultant, okay? When you want to consult on how to set up cameras for data retrieval, the camera must be a high resolution capturing device. Tak apalah dia akan makan you punya storage device. A good company should spend on a very big storage device so that all this data can be gathered. Kat Malaysia ni masih lagi rendah pasal data gathering, alright? So gather the images, right? So later when you do pre-processing or processing, you would have a much better option on how to do enhancing or processing of the images. Kalau image tu memang awal-awal dah rosak kan, you tak boleh buat apa-apa. You cannot do much. Alright, you can actually do processing, but it's limited to whatever that you have. Alright. So kalau gambar tu awal-awal dah sharp, lagi bagus. Alright. So this is the last slide for this one. Okay. So image processing and artificial are two different things. So image processing is complementing artificial intelligence. So, artificial intelligence in general lah. Contoh feature extraction yang ditunjuk dekat sini adalah ini. This is the feature image. The image processing is the feature extraction. So AI method is complemented with the feature extraction so that this feature extraction can be an input to the AI method. So AI method can be machine learning, it can be fuzzy inference, it can be evolutionary algorithm, right? So depending on the model or AI method that you're using, you may probably do prediction, recognition, or probably representation and transformation of the image itself, right? So boleh jadi macam-macam. You boleh clustering, you boleh buat apa reconstruction. Reconstruction ni under representation and transformation lah. You can do classification, right? So there's so many problem that you can tackle by using different AI method. Bukan sahaja ANN sahaja ataupun machine learning. So you ada belajar kan fuzzy inference. So fuzzy inference pun sebenarnya boleh juga proses information daripada feature extraction of image processing. Contohnya macam image tu kan, kita cari katalah saya hantar agent guna apa tu, kita panggil yang end optimization. Dia ada banyak, saya tak ingat evolutionary algorithm. Dia ada yang macam hantar agent, macam contoh agent tu kan, agent tu sebenarnya is an average pixels lah sebenarnya. So katalah kita ada satu image yang besar kan, saya tak nak resize image tu tapi saya nak tahu image tu sebenarnya dia colour apa, the colour region of the image itself. So saya hantarlah beberapa agent ni sebenarnya dia check dia colour pixel tu. So a good agent will find the contrast of the images itself. Alright, so sometimes ada benda kontras tapi dia kecil je benda kontras tu. So if you have a very good agent, so the agent will take up that image contrast tu, tapi dia ada macam some sort of strength lah. So the lesser the the area of the color itself, so the strength of the agent is very weak, right? Kalau area dia yang di cover tu besar, the strength of the agent is quite strong, right? So this agent can give information to AI methods such as fuzzy inference, neural network, right? So especially evolutionary algorithm, right? To process this information into something that is meaningful, right? So that it can do prediction and recognition, for example lah. Okay, saya bagi contoh lah, macam fuzzy inference kan. You ada belajar tak fuzzy inference?
Ada.
Kan, fuzzy inference,
Ada.
kita ada macam some sort of universe of discourse of X kan. So the universe of discourse of X can be any value that have range. So dalam image apa yang ada range?
Color ada range?
Yes, kalau ada range kan, red, green and blue kalau you pakai RGB lah. Kalau you pakai CMYK, so you have 4 different values, CM, Y and K. So these different values and combination of these values would probably be something that is meaningful, alright? So mungkin the combination of RGB will produce another color. So this sub color will probably be a representation of another analysis through the inference. So fuzzy inference yang you belajar tu selalunya rule dia satu je kan, dia macam you ambil, you ada satu je processing elements of the fuzzy inference. Sebenarnya you can have an inference that produce an output for another inference. So fuzzy inference you tu macam nested fuzzy. Okay. So again, throughout whatever that you learn through the semester kan, memanglah dia ajar yang basic, tapi bear in mind you can always alter the AI method that you have already learned, right? In order to alter that processes, you need to understand the basics first, because when you do altering, you have to know lah why you do the altering. Kenapa you buat? Kenapa you do changes on the processes that you have already learned? Because you understand the process itself. You understand why this process is being done and how would it affect the overall process of the AI method if that particular step is changed. Okay, kalau you boleh ubah AI method tu, maknanya you faham lah dia punya step-step dia tu, dan bila you ubah, you tahu apa yang akan berlaku kalau you ubah step dalam AI method tersebut. Sama macam evolutionary algorithm, you belajar ada mutation and crossover kan? Betul tak? Did you learn about that? EA? Ada belajar EA?
EA?
Evolutionary algorithm. Tak belajar lagi?
Belum.
Okay. Dalam evolutionary algorithm ni macam genetic algorithm. Pernah dengar genetic algorithm?
Baru belajar.
Baru belajar, okay. Okay, sebenarnya you dah belajar dah. You pernah tengok cerita Piramli?
Yang mana satu?
Yang mana tu? Cerita Nujum Empat Belalang.
Pernah.
Kan? Dia ada ajar kan dalam tu pasal EA. Ada tak?
Yang itik tu lah.
Dia ajar pasal tu yang apa tu, satu banyak, dua jarang dia kan. Dia ajar tu.
Oh, faham.
Kan? Lepas tu even dalam Islam pun kalau you nak cari jodoh kan, dia ada berapa kriteria yang dia bagi tu kalau you nak cari jodoh. Apa kriteria yang you kena tengok?
Untuk lelaki pilih perempuan rasanya
Cantik.
Cantik lagi. Betul, cantik.
Kaya.
Betul.
Agama.
Kaya. Agama lagi. Cantik, kaya, agama. Lagi satu, ada 4.
attitude.
Ilmu.
Pudi.
Agama tu ilmu lah. Agama tu ilmu. Lagi satu.
Sopan
Lagi satu
santun bukan
kan.
bahata,
Apa lagi?
bahata.
Macam mana? Macam mana? Bahata, bahata. Kaya tu bahata je. Cantik, bahata, ilmu sih. Keturunan. Ada orang dah jawab kan. Keturunan. Okay. So, evolution algorithm ni, dia ada kena mengena dengan survival of the fittest. Pernah dengar teori survival of the fittest?
Yang
Okay, survival of the fittest ni maknanya kromosom yang lebih fit akan menjadi next generation. Mana-mana kromosom yang tak fit kan, contohnya yang lemah, yang tak kuat, dia akan pupus lah. Okay, hanya yang kuat saja yang akan survive. So sama je macam manusia. So that's why the reason for apa tu untuk yang nasihat dalam kita dan Islam kan, kita kena tengok 4 kriteria tu, yang cantik, yang apa tu ada harta, yang apa tu beragama dan juga keturunan kan. Sebab agama tu maknanya termasuk ilmu lah. Alright, so if all these 4 criteria are actually enforces the survival of the nature itself. Maknanya kalau orang yang cantik ni, dia akan menjadi pilihan untuk generasi yang seterusnya. Faham tak? So cantik juga menunjukkan yang keturunan tu adalah keturunan yang baik. Dia tak ada penyakit kan? So bila dia tak ada penyakit, maknanya the chances of the apa tu next generation to survive is greater. Tapi dia kata ultimately, kalau nak survive, pilih yang mana satu dari 4 tu. Mana yang kena pilih? Dia ada 4. Dia ada 4. Kalau boleh, dia pilih yang ada 4-4. Tapi kalau dia tak ada pilihan, dia pilih yang mana?
Agama.
Yes, pilih yang agama. Okay, that's the last resort. Kalau dah tak ada pilihan, pilih yang beragama. So selamatlah you. So bila ada agama, maknanya ada ilmu. So kalau ada ilmu, the chances of survival will be higher. So itulah dia. Dalam agama pun dia dah ajar dah sebenarnya evolutionary algorithm. Cuma you tak perasan je lah. It is actually EA sebenarnya. Sama macam fuzzy tu lah, yang penujung 4 belalang apa tu, satu banyak-banyak tu kan, itu fuzzy lah, fuzzy inference. But you did not realise that you have already learned it previously. Alright, so any question? Ada soalan?
tak ada. InsyaAllah.
Tak ada kot saya.
Okay, so next kita tengok ada lagi satu slide. Nampak tak ni slide ni? Can you see the slide, the next slide?
Yes.
Okay, so in this slide it mentions about, ni author of the slide, so it mentioned about preprocessing, right? So dalam slide ni dia ada banyak technical punya calculation and all, so you can ignore the technical calculation because I want you all to focus on the technique itself. So in this slide, it explain about preprocessing. So preprocessing is a common name for operation with image at the lowest level of abstraction, both input and output intensity images. So the aim of preprocessing is an improvement of the image data that suppresses unwanted distortion or enhances some image features important for further processing. So you dah ada dah, selalunya preprocessing ni dia adalah secondary data yang you ada dan you nak further process so that it can fit into your AI model. Okay, contohnya macam AI model you hanya nak RGB je, so you processing untuk dapat RGB. Ataupun you AI model you dapat edges, nak edges saja, you nak black and white, so pre-processing will process that into black and white, and so further on lah. So let's look at the category, right? So even though, okay, bear in mind, even though there are 4 category in this slide, okay, the 4 category of image processing method according to the size of the pixel neighborhood that is used for the calculation of a new pixel brightness. So kita ada pixel brightness transformation, geometric transformation, preprocessing method that use local neighborhood of the process pixel and then image restoration. However, there are many subcategory. Okay, subcategory under these 4 category. So banyaklah sebenarnya. So kalau ada soalan contohnya, what are pre-processing technique that is used in order to help AI method to do classification, for example. So ada banyak lah, ada image enhancement, ada brightness and contrast enhancement, ada image resizing, right? So this slide, I took this slide so that it can be of a reference on what are the technique or what are the method that is available to do image enhancement or restoration, right? So dia kata kat sini, image processing method use the considerable redundancy in images. So neighboring pixel correspond to one object in real image have essentially the same or similar brightness value. So kan ada saya bagi satu contoh kan yang previously yang kita identify Lego kan, yang Lego toy last week. Remember? Ingat tak? Ke you tak masuk kelas? Kita cakap seorang-seorang.
Ingat sir.
Okay. Alright. So from that example, you can see that I have set up a color range so of the object that I want to segment. Right. So saya tahu dah Lego toy tu warna dia biru. But because of illumination, I have to set a range of blue color. So that's why dia ada noise lah. Range of blue colour saya tu ada termasuk dengan background sekali. So probably I have to adjust the range of the colour so that I can exactly extract the image of the object that I want to extract. Right? So that is an example of neighboring pixel lah. So pixel yang berdekatan colour dia dikira sebagai satu objek yang sama. So if preprocessing aim to correct some degradation in image, the nature of prior information is important. Macam saya cakap tadi lah, masa kita nak capture data tu kita dah tahu dah. Kalau contohnya gambar tu noise dia sebab gelap, so kita tahu dah macam mana nak solvekan problem tu because we know the nature of degradation, right? Kalau disebabkan noise, so kita tahu macam how to handle that, right? Knowledge about the properties of the image, acquisition device and condition under the image was obtained. So it is very important again. This is again emphasize that when you want to capture the image, you have to be very sure and careful what you're doing. Maknanya you don't simply ambil gambar saja untuk data you. Kalau macam zaman COVID ni, banyak research topik dicadangkan supaya you pakai je data daripada Kaggle, data daripada UCI website, right, to do your research. But previously, before the pre-COVID punya time, you can actually collect your own data. So bila you collect you punya data sendiri, the problem is that you don't simply collect macam tu. Ada case-case macam student dia ambil gambar tapi gambar tu dia main ambil je. So later they will have problem in determining or doing pre-processing or doing even nak fit dalam model pun dia akan ada masalah. So if knowledge about object is not available in advance, it can be estimated during the processing, right? So don't worry, sometimes data you memang you tak tahu apa-apa tapi as long as your data is consistent, you can do something about it, right? Consistency is also important because kalau tak consistent, then you have problem lah. So because pattern is about consistency, right? So kalau you punya data, especially images, kalau data you tak consistent kan, kejap-kejap data tu berubah warna, kejap-kejap dia punya gambar tu ada distortion, kejap-kejap tak ada distortion. Especially saya bagi satu contoh lah, macam gambar muka, for example, you nak recognize muka, tapi dalam data you yang you train, dia ada distortion, alright? Especially contoh Pernah tengok tak yang dulu iklan laptop, dia boleh recognize user guna facial recognition kan? Ada kan?
Nah.
Lepas tu dia stranded, dia naik kat terbang, lepas tu stranded dekat pulau, lepas tu dia punya muka dia apa tu, dah tumbuh misai, tumbuh janggut, lepas tu dia balik rumah, buka laptop dia, still laptop dia boleh recognize face dia lagi. Ada? Pernah tengok iklan tu? So yang
Tak pernah je.
Tak pernah.
apa yang dia cuba sampaikan adalah face recognition tu dia tidak mengambil kira face distortion. Maknanya the recognition of the face itself would exclude your facial hair. Dia akan tengok benda lain. Maknanya nak recognize you as yourself, dia tengok dekat mungkin shape of your face, benda-benda yang tak berubah. Okay. Benda-benda yang tak berubah ni lah consistency. What is consistent about you? Apa tu, benda yang boleh berubah adalah contohnya hidung. As you age kan, bila you umur you semakin tua, hidung you akan sentiasa besar, dia akan membesar, berkadar terus. So kalau you panjang umur kan, you immortal ke, hidung you besar. Okay. Right, so my point is that you have to look into something that is would not change over time, so that you would catch the consistency of the pattern. Right, so this is another processing technique, which is pixel brightness transformation. Ini very straightforward lah. So brightness transformation, modify pixel brightness. So apa-apa image kita boleh terangkan, kita boleh gelapkan. Right, so this is also a problem in images, right, where sometimes when you take an image, sometimes the image can have a problem in brightness. Okay, ada juga yang dia faham, okay, when I want to capture an image, I need light kan, so dia pergilah cari light source yang banyak. So an easy light source would be to take picture outdoor and during the day. However, orang ni dia lupa tentang overexposed image. Dah dengar overexposed?
Nah.
Kan? Especially the girls kan. You all ambil gambar selfie dekat tengah hari kan. You pergi keluar tengah hari tu, cahaya banyak, you selfie. Lepas tu, muka you banyak peluh kan. Peluh tu dia reflect cahaya. So nanti bila you ambil gambar, muka you jadi putih. Tapi putih dia tak konsisten lah. Dekat mana yang ada peluh tu, dia akan ada macam tumpuk-tumpuk putih dekat muka you. So that is what we call as exposure, right? Overexposed image, right? So overexposed image is also some distortion lah in images. So we can also fix this in by doing brightness correction, right? So again, brightness correction perlu dibuat semasa you retrieve the image. Maknanya nak capture image tu, you dah you dah awal-awal dah consider about overexposed images. So because kalau you dah capture dah overexposed image, boleh lagi nak betulkan sebenarnya, tapi it would take a lot of processes, alright? So again, you want to avoid processing yang banyak, so you would take the image correctly the first time, right? So maknanya sebelum ambil gambar selfie dekat luar, lap dulu muka, tak nak muka berminyak, baru ambil gambar, alright? Okay, so next. Position dependent brightness correction. Okay, ideally the sensitivity of image acquisition and digitization device should not depend on position of the image, but this assumption is not valid in many practical case. So sometimes kita tengok juga dekat position brightness dia. So especially uneven light sensor ni lah, uneven object illumination yang tadi overexposed kan. You ambil gambar, tudung you terang, lepas tu tudung you punya pattern tu, gambar bunga dia hilang dah sebab too much light. Okay, so that is degradation. So susah lah kalau you nak retrieve balik pattern tudung tu. So kalau you nak jual tudung ke kan, mesti ada model kan nak pakai tudung. So tapi kalau you ambil outdoor, gambar model yang pakai tudung tu overexposed, so tak nampak lah dia punya pattern tu macam ni nak jual produk. Tak boleh kan. So you have to know how to capture the images so that the pattern is retained inside the images. Alright, so kalau you nak buat processing pun dah tak boleh dah. Nanti probably it won't be the same pattern. Alright, so ni dia punya calculation, tak apa boleh ignore je calculationnya. So kita nak tengok dia punya processes. Alright, so this is another process which is Grayscale Transformation. So it is very straightforward. You ada color image, tukarkan kepada Grayscale. Grayscale tahu kan? Tahu tak? It's black and white, right? Black and white image. Tapi dia bukan exactly black and white. Dia ada a gradient of value between black and white. So black is the lowest value, which is 0. A brighter value, which is white, is 255. Alright, so dia just tukar je gambar apa tu, color kepada gambar hitam putih. Alright, so ini calculation lah, boleh know. Right, so this is histogram. So that for people that doesn't know how histogram looks like, so histogram is a frequency analysis of the pixels of the images. Maknanya pixel yang warna macam ni berbanyak, warna macam ni berbanyak. So by looking at this histogram, kita dah boleh interpret dah gambar ni macam mana. So ni objek dia. Okay, selalunya objek ni akan berada di tengah-tengah lah. Dan background of the object would be either bright color, macam ni bright color lah. Background dia mungkin putih, seakan-akan putih. Tapi kalau background dia dark color, frekuensi dia akan berada di sebelah kiri. So this is two different histogram. So you have the original image and the equalized histogram. So mana-mana yang value yang dia rasa macam noise kat bawah-bawah ni kan, yang rendah ni, this is noise. So dia buang dan digabungkan dengan frekuensi yang terdekat, so dia dapat nilai yang macam ini. Right. Geometric transformation is mostly to fix distortion. Okay. So contohnya macam ni, image yang ada distortion dibetulkan balik jadi macam ni. Okay, so this is the explanation. Tak perlu tahu sangat. Yang you perlu tahu adalah that there is a geometric transformation, right? So ada banyak lah under geometric transformation, ada lagi sub processing method, alright? Okay, and then so this is another processing technique, brightness interpolation. So apa tu brightness interpolation tu nanti bacalah. So yang akhir-akhir ni more to interpolation of images, alright? So ada banyak lagi sebenarnya contoh of image preprocessing. Nanti saya cuba kumpulkan lah apa processing technique yang ada dan apa yang dibuat, and I will share with you all later, alright? So I think that's all for today punya session. But before I end our session, I would like to ask all of you, ada soalan tak?
Kalau gambar tu dah diambil awal daripada grayscale, so dia akan tukar ke color balik, tak terjadi masalah lah.
Okay, good question. Macam mana gambar grayscale kita nak tukarkan balik kepada color? Tak ada masalah kalau you ada some sort of prediction of color. Maknanya kalau you tahu tu adalah muka orang, kan, muka orang, and then you would be able to predict the skin color of that grey value. Maknanya kalau grey value tu in a certain range, probably kulit orang tu dia warna apa? Dia warna apa tu, macam kulit orang Melayu ke, atau ada kali macam kulit masalih ke, ataupun dia macam kulit orang India ke, for example. So apa tu, changing from color to grayscale is quite easy, but changing a grayscale to RGB will need some sort of prediction. You can ada previous student saya, dia buat manga colorization. Apa tu, manga yang black and white tu kan. So dia nak reduce the job of the mangaka. Mangaka will spend more than 8 hours a day to produce his manga lah. So by having the research on manga colorization, it is hoped that it can somehow reduce the process, right? So apa yang dia buat adalah daripada manga punya karakter tu kan, so a black and white panel dia colourkan, right? So dia kena tahulah based on the pattern itself, macam contohnya masalah manga Japan ni, the skin colour tu can be unpredictable. Contohnya macam karakter tu sepatutnya skin colour dia warna hijau contohnya kan. So mungkin dia ada misclassification of prediction, jadi karakter tu sepatutnya warna hijau tapi dia jadi warna skin colour, for example. So that is some of the challenges that may be of an interest later. Okay? Boleh?
Okay.
Did I answer your question?
Yes. Thank you so much, sir.
Lagi soalan lain? Ada?
Sir, test
Test.
esok ke?
Test kata ada orang cakap dia nak minta postpone sebab you all banyak sangat apa tu assignment. So ramai yang mesti saya minta pindah ke next week.
So next week Khamis lah, sir. Okay.
Tak apa lah, no problem sebab kalau you nak hantar lambat sikit ke, maknanya at the end of the 14 week tu you can still submit your apa tu, your
Group project.
Group project, yes.
So means kalau Ahad pun boleh lah.
Okay, yang itu kita bincang esok. Boleh?
Okay, boleh.
Sebab esok everybody will be with us for the 3 group, so saya boleh terus bincang hari esok how to conduct the test session. Ada orang mungkin dia tak nak buat luar daripada class session. Ada orang mungkin prefer Sabtu Ahad. We will discuss about that.
Okay, thank you, sir.
Tak ada pilihan, tak payah kahwin. Betul lah. Tapi kalau ada pilihan, boleh lah. Kan? Betul tak? Dulu pernah dengar cerita sahabat Nabi dia tak nak kahwin. Lepas tu Nabi marah. Nabi kata tak boleh kan. Kalau you mampu, kena kahwin. Sebab kalau semua orang Islam tak kahwin, nanti tak ada keturunan. Orang Islam semua pupus. Lagi soalan lain?
Tak ada, sir. InsyaAllah.
Alright, so if you don't have any questions, so let me download your attendance first. Okay, so that's it for today. Thank you very much for attending my class session. So I will meet you all again tomorrow.
Thank you, sir.
Thank you, sir.
Okay, welcome.
Thank you, sir.
Thank you, sir.
Welcome.
Thank you, sir.